Okay, well, we might as well get started. If other people join us, they'll just miss the beginning a little bit, but we can always recap. So my name is Dean Jack. Can everybody see my screen? I guess that's the most important thing right now.
Yes.
All right, perfect. So we're iDESIGN. If you're in California, your rep will be Stephen Gutterman in the bottom right corner. I don't know if you've met Stephen, but he's very knowledgeable. He got his start the same way I did, as a VEX coach. So he's a great resource for you if you need information, parts, help with events, anything like that. There's also the rest of the team, obviously Andy and Mario, our co-founders. And then I do all the training, support, and I also do Canada sales. And we've got Sarah with us today. She is our marketing guru who makes us all look good. So a little bit about iDESIGN. We're not just VEX Robotics, although it is our premier and our #1 product. We also do 3D printing, laser cutting, and software as well. So today we're going to talk about VEX IQ, and we're going to focus on the hardware side. So the parts in the kit, what they can do, etc. It is a small group, so feel free to stay unmuted. And if you've got any questions as we go along, please just ask away. This is for you. So what is VEX IQ? The most important thing about VEX IQ is it's an affordable robotics platform that's designed for young students. And the way it's designed for young students is because, as you know, it snaps together very easily and allows them to do open-ended challenges, meaning that they can modify their robot and have some fun with it very easily while they're learning engineering and coding. Why VEX IQ? The #1 thing is student engagement. And I'm sure working in the classrooms and working on teams with VEX, you notice that the students really do become engaged, where they're bothering you to work on their robots on their lunchtime, maybe asking if they can take them home. But the most important thing is it uncomplicates complicated engineering concepts. And thankfully, it's easier than that sentence. So the idea is that students are having fun, but they're learning at the same time. So we're going to talk a little bit about the challenge. This year, the challenge is VEX IQ pitching in. And have you seen the videos already? You're aware of the challenge? Great. So we know this one is about getting those balls into the high goal or into the low goal. And then at the end, we're going to get our robot to hang. And we know that there's different challenges. There's the teamwork challenge. And then there is also the coding challenge, which is the one that's probably the biggest challenge for everyone. But we're going to talk about both sides of that equation. As you're aware, you can register events on robotevents.com. And last year for Rise Above, there were quite a few events in the United States. And the year before, there were obviously a lot more because we hadn't hit COVID yet. So hopefully we're going to get back to a little bit of normalcy where we're going to have more events, which are going to give the students a lot more chance to go out and compete. How many events do you generally do per year?
I think it's 5, yes.
Oh, wow, that's fantastic.
5, either 5 or 6, I can't remember, several of them.
Right, excellent.
State competition, if you win, then you go to state competition.
Right, perfect. All right, so you're already well aware of how to start your own team and how to register. No questions about that?
No, we already did. We registered the team. We have 2 teams.
Perfect. And you've got all your equipment, so you're aware of the different bundles.
We got them. Mm-hmm.
Right. So we're going to talk about what's in the kit, just to make sure you're getting the most out of the kit. So you're already aware that there's a robot brain. You're aware of how the controllers work. For the smart radios, do you use iPads or anything like that for coding, or do you just use PCs?
Last year I used PC.
Okay.
I don't remember using radio. It's something new for me.
So this radio should be included in your kit. There's 3 different colors of radio. The oldest ones were black, then the newer ones were gray. The newest are blue. All the radios work.
Probably, yeah, I can't remember. Maybe do we do it only the first year and that's it? The radio.
Yeah, so the radio is already put in your controller. I don't know if you can see my camera, it's pretty small.
Yes.
So the radios are already installed. The only reason I mention is the blue are smart radios. And if you have the ability, you can actually code the robot wirelessly with the iPad or with Android devices. So rather than having the students plugging and unplugging, plugging and unplugging the robot every time, it does give you the functionality, if you wanted, that you can code the robot wirelessly. It is a little bit slower, but some teams do prefer this method.
Okay, so with the radio.
Yes, with the blue radios. So check which radios you have. There's one in the controller, and then there'll be one stuck in the robot brain, and they're different colors. If you have the blue ones, you can code wirelessly. If you have the gray or the black, you would need to purchase the blue ones and change the radios, and then you'd be able to code wirelessly.
Okay, thank you.
No problem. So the smart motors, the reason they're smart motors is because they have feedback. So it's not a motor that we can just turn on and off. It's a motor that actually gives us feedback, and we know how to use that in the coding. I'm hoping that you're using the new VEXcode software for your teams, and you're not using Robot C or Mod Kit anymore. Do you know which software they're using?
Well, I have it in my, no, we downloaded. Okay. So if I'm understanding it correctly, okay, are you talking about, I think I do use the software, whatever they send it to us every year.
Okay, perfect. So you're using the new software, the VEXcode, which looks like Scratch.
Yeah. Yes, it looks like.
Okay, perfect. Because we do still have some teams that are using the older software, which still works, but it doesn't work as well as it could. So that's great that you're using the latest. So we're going to just go through the sensors. So bumper switches are great for limit switches. So at the end of mechanisms, so if you've got arms that move or things like that, this is a great way to make sure that they don't go too far and break the robot apart. It can also be used in autonomous if you want to use your robot for what we call a hard stop, which means if you wanted your robot to drive and actually hit the wall so you know exactly where it is, it's another sensor that can be used right on the edge of a robot that some teams use very successfully. Mm-hmm. The touch LEDs, my students love them because of the different colors. They call it blinky, and it allows them to add a little bit of style, a little bit of fun to the robot. But where I really use it is I use the touch sensors to start the code, because I find that once the robots are built and they're getting them all set up, it can be challenging to get to that check mark. So this is a great way to get them to start the robot, have the gyro calibrated, and be able to just use the touch sensor to start either their first code or multiple codes. Mm-hmm. The distance sensor is probably the most unused sensor in the kit, but it is very powerful because it can measure distance. It's not really great at doing distance to field objects because they're usually not solid objects, but it's a great way to know the position of your robot from the edge of the field. I've seen teams use it on the back of the robot, and they can measure how far the robot is from the edge to make sure it's in the right position. We also have the color sensor, and the color sensor gets used basically just for measuring color. So I don't see a lot of use in it for this game, but it can also be used to find the lines on the field, depending on what the students need in the way of coding. And probably the most important sensor is the gyro sensor, because this lets us actually measure how far the robot is turning when we're doing turns. So I'm hoping that you use the gyro sensor on all of your robots, because that's really important, especially when we get to the code.
I'm here to learn how to use this one.
Perfect. We've got structures and connectors, of course. The parts poster, this is probably the best thing VEX ever did, was making a one-to-one scale parts poster, because students can actually make sure they've got the right part, especially if they're building, for instance, the newest robot for this year's game, where they're going to maybe be using some pieces they haven't used before. It makes sure that they can check and find the exact piece. One thing I like to mention is the part numbers on this sheet are really, really long, but if you look closely, you'll find out that the first digits of every part number is 228-2500, which is actually the VEX IQ Super Kit. So I explain to my students, when you're looking for a part, just look for the last 3 digits. Don't worry about the whole part number. So if you're looking for a 228-2500-063, just look for the 063. It's much easier for them to remember. Of course, it comes with the bin and the tray and the build instructions. So the build instructions actually allow you to build 4 different robots. You can build just the drive base, you can build the clawbot, you can build the clawbot with sensors, or you can build the autopilot. So do you usually start your students off every year with them building one of these builds, or do you go right? Yes. And which one do you usually use?
The first year we used, let me read to remember. I think we did, no, we didn't do Clobot. Was there any other? I can't remember these names.
There's always what VEX calls a...
Yeah, I used to build different ones.
Right. So there are, actually, we can go to the next slide. Every year, VEX gives us a new build. So this year, the new build is in the top left corner, and that's a robot that's actually designed for this year's game. Some of the feedback is it is a very complicated robot, and it is not built that robust, but it is a great starting point for students that want to learn how to build a catapult.
Okay, so top left corner?
Yes.
And what's the name of the robot?
The name of that robot, that is a great question. Let me just take...
Fling.
Fling, that's right, yes.
What is it? Fling?
Fling, yes. So it flings the balls, yes.
Okay, let me take notes.
No problem. Now, one thing I should mention is I'm not sure if that is the best robot to start your students with, unless if you've got a group of advanced students that have already built robots, that would probably be a great start for them. But if you've got any students that have never built a robot before, that might not be the best place to start. You may want to start with something like an autopilot or a clawbot, just to get them used to the way the parts work, and especially get them used to coding. So as you know, VEX has instructions in 2 different ways. They do have the ones which are just PDFs. They're just basically instruction booklets, much like you'd see with Lego, but they also have the build instructions where it's almost like a video where you can actually see how the parts are going together, which some students find a lot easier to relate to. I always like to remind teachers that VEX is about more than just robots. So if you really want to inspire their creativity, they need to learn about all of the different segments of VEX and all of the different mechanisms that they can build. So this was an experiment I did at home where I just went through all of the VEX lessons and found all the different mechanisms and built just basically a contraption. And you can see how it works here. So this was just something simple, but it showed the students about leverage, about weight, centrifugal force, gearing, etc. So most importantly, and I know you already mentioned it, the battery, the battery, the battery. Always make sure your batteries are charged. And it's probably the one thing that I recommend every team is buy extra batteries, because as you've probably noticed, when that battery gets below 80%, it doesn't seem to listen to your code at all. It listens about as well as the kids do after 4 hours. So now you've got your robot just having a mind of its own. So I always make sure that we've got batteries on charge and extra batteries.
Yes, we do have extra. We ordered already this year too. We ordered last year, and since in the letter they said, so we did not do anything for a year or 2. So the may not work very well. So we ordered 3 or 4 of them.
Excellent. Another thing I should mention is when you're charging the batteries, you'll take the battery, you'll put it in your charger, and it'll charge up and it'll turn green. If you take that battery out and let it cool for about a half an hour and put it back in the charger, it'll charge for probably 15 to 20 more minutes and top it all the way up. So that's one thing we learned, especially before competitions, is I would always double charge the batteries, and you'll find that they last a lot longer. And what it is, the charger actually checks the internal resistance of the battery. But when we're charging these batteries, they get hot, and heat creates extra resistance. So the charger thinks it's fully charged and shuts off. But if we let the batteries cool and put them in one more time, it will charge them up to 100%. So that's another little trick that will help you out, definitely. And the one thing I have found is I've been doing this for 6 years now, and my brand new batteries and my 6-year-old batteries all seem to work the same. These batteries don't seem to get a memory or die out. So just charge your batteries up, double charge them, and you should find that your old batteries work just as well as your new ones.
Thank you.
Firmware updates, you're familiar with those, I hope. You've done them before. Excellent. There have been some new firmware updates recently, so you'll need to update all your robots, and that's to do with the new features in VEXcode, which I'll talk about on Thursday.
Okay, may I have one question very quick?
Of course.
I used to use PC before, and I have this on PC, and then I keep updating it. But now I'm using Mac. Do they have one for Mac or no?
They do have one for Mac. It does work, but it's a little trickier. Sometimes you need to unplug the brain, plug it back in, and if it won't work at all, you'll need to restart your computer.
Oh, okay.
But once you've got it working, what I recommend is get all your robots together, get it set up, and then update all your robots at the same time. It's much, much easier. But it does work on Mac as well. It's just a separate download.
Mm-hmm. Thank you.
Have you used the STEM labs at all, the VEX lesson plans?
No.
So
I noticed that this year. I did not see it before, but I was observing this year. I noticed STEM lab. There were some lessons before, but I don't know if they were called STEM lab or.
That's 100.
Used those lessons before.
That's 100% correct. These are new, and what they are is they're new and improved lesson plans from VEX. So now I don't know how much time you get to spend with your team. Some teams spend a lot of time. Some teams only get one a week. So depending on how much time you have with your team, sometimes choosing these STEM labs is a great way to let your students explore on their own and learn about their robot, whether it's about mechanics, whether it's about sensors, whether it's about coding, etc. Make sure if you are going to use the STEM labs, though, that you sign up for the teacher portal, because the teacher portal has all of your extra resources you're going to need, like list of materials, overviews of the STEM labs, etc. So the ABCs of robot triage. So basically when something doesn't work, and you've been doing this for a while, so you're probably aware of this, always make sure everything is plugged in. I get year after year, because I do support as well, we get students that say, you know, a motor doesn't work. And what it really comes down to is these cables can be plugged in, not all the way, and they look great, but you really need to hear that click sound when they go together. So if you're having issues, always, I just go around the robot, both sides, make sure all the cables are in, make sure your batteries are fully charged, and make sure your controller and brain are paired. I'm sure you know how to do that with the networking cable. Right, perfect. And then the other thing that we see a lot is making sure that the drive shafts are actually fully inserted into the motor. Because if the drive shaft isn't put in the motor all the way, the motor's going to run, but whatever it's driving will not work. So my last tip and trick is a little video, and I had to make this as a video. I would prefer to do it live, but unfortunately, if I fire up the robot and hold it in front of the camera, you can't see anything because it's backlit. So I actually did this video last year at nighttime so everybody could see it. And one of the things about VEX that I love, especially the VEX IQ, is that the students can build a robot and test it and make sure it does everything they want it to do before they start trying to code it. Because that takes out of the equation, is it the robot or is it the code? If they can drive the robot and use the controller and the robot does everything they want it to do, then they already have that confidence when they move to coding. But there's a lot of things you can do with the menu, with just the actual robot brain to help enhance that. So I'm going to click play on this and let myself take it away. Quite challenging to get a good video capture of the LCD display on the VEX IQ brain. So we have to do it in a dark room or at nighttime in my case. So that's why this is going to be a recording instead of me showing you how to do it live. So when we first start the brain, it comes up with driver control and demos. If we choose driver control, it gives us three options. Run, which will let us use the pre-configured software with the joystick to drive the robot around. There's also configure. If we go to configure, use the up or down arrows to navigate and then the check mark to move to the next, you'll notice that we can change control. So using the check mark, we can change it from right stick to left stick or to two joysticks. We can also change any of these options below it from normal to reverse. So if we built a robot and it drives backwards, it's easy just to come in here and change the configuration. Use the check mark to change it, and then the X to save it. Okay. We can also reset to default, which is going to reset all the settings back to the factory defaults. From this menu, there's also demos. So these demos are going to give you some sample code that goes with the autopilot robot and with some of the tutorials. From the main menu, if you hit the X or the back button, it brings you to this menu, and this menu gives you system info, device info. So system info tells you things like battery voltage, radio data, and it also gives you the ID number. That ID number is what you're going to need if you want to program wirelessly with your iPad or Android device. We can also turn the sound on and off. We can calibrate the controller. We can tell it where we want it to start, which menu when we first start it up. Again, we can reset all settings, erase user programs, and this is where you turn the smart radio on or off if you want to use it with wireless devices for programming. We're going to scroll up to the device info. The device info allows us to scroll through, and there's smart ports. So there are 12 ports on here. The brain automatically detects what's plugged in. So it knows, for instance, that we have a motor plugged into port number 1. If we turn this motor, you'll see that we actually get data. And it's going to tell us the speed of how fast I turn it, the angle, as well as the number of turns. We can also hit the check mark. And as you can hear, it's a little dark to see. The motor starts turning, and we can adjust the speed with the arrow keys. We can also hit the check mark and turn it off. So on port 1, we've got a motor. What have we got hooked up to port 2? Oh, we've got a distance sensor. So right now, the distance sensor is not seeing anything. But if we put an object in its way, you'll notice that it shows us the distance in millimeters as well as in inches. So it's a great way to test if the distance sensor is working and to measure how close you are to an object. Port 3, we've got the color sensor. So the color sensor has 3 different modes. It's got a 3-color mode, it's got a 12-color mode, and it's got a grayscale mode. So if we go back to the 12-color mode, we can now see that it'll tell you different colors as it sees them. It'll do the same in the 3-color mode. And in the grayscale mode, instead of giving us a color, it just gives us a value. So it gives us a different value of how much gray or how much darkness it sees. It also tells us the distance, whether it's close or far away. Because it's a little dark in here, it's going to give us a bad reading and tell us that everything is close. But with lights on, it works quite well. Next is the gyro. So the gyro is basically an electronic compass that tells us what angle the robot is on. So when we start the robot, that's always 0 degrees. And then as the robot drives around and turns, you'll see that the degrees do change. So the gyro works really well in the software for making those crisp, sharp 90-degree and 45-degree turns, or whatever angle you want to be able to have your autonomous work very well. Port 5 is the touch LED sensor. And you'll notice that it's lit up. And if we touch it, we can change color. And you can see that it tells us whether it's pressed or released and what color it's showing. Port 6 is another motor. Again, if we hit the check mark, we can get that motor turning. We can test that everything's working, everything's hooked up. And we can also check what different speeds will do. Again, hit the check mark to stop the motor. So it tells us if we've got anything plugged into the port. So if we had something plugged into this port, obviously we would have an issue, but since we have nothing plugged into port 7, everything's fine. Port 8, oh, we've got a bumper switch. So as you can see, it shows us the state, pressed or released. So this is how the device menu can be used to verify that the sensors are working and also give insight into how they work and what kind of readings you can expect. All right. So in summary, VEX IQ is the perfect introduction into robotics. The competitions keep students engaged and learning. And you can always reach out to us for help or support because we do offer training as well as support on the VEX product lineups. And hopefully we're going to see you all Thursday to learn about the basics of coding. And then next week, we've got more advanced lessons on the gyro. And right now we are going to open up the floor to questions and answers. So if you have any questions at all, one of the main reasons that I explain about how to use the device menu, especially in relation to the motors, is when you want to start coding a robot. Let me just jump out of this presentation. You know, one of the things I see with students is if they're taking something like this Clawbot robot and they're grabbing an object and lifting it up, is I see them trying different numbers, just guessing, saying, well, let's try 30 degrees or let's try 50 degrees to know how far they need to close the claw or lift the arm. But with what I've just shown you with the device menu, your students can actually go to that particular motor, in this case, motor 11, and then when they lift the arm up manually, it'll actually tell them the actual value of how many degrees or how many turns it is to get to that position, and they can enter that directly into the coding and get quickly much further ahead without all of the guesswork. So I'm not sure if your students were aware of that, but that is a real game changer as well and takes a little bit of the frustration out of coding. So at this point, do you have any questions? Any questions about any of the hardware, or do you want me to take a look at the lesson plans with you or anything like that at all?
I think you're muted, Alita.
Yes.
There you go.
It's possible to show the STEM lab since
Yes.
it's for me.
Absolutely. Okay. So hopefully now you can see my screen that says VEX Robotics.
Mm-hmm.
So if we go to the right, we've got STEM labs up on the top right. And then of course it lists all the different STEM labs. Today we're going to look at VEX IQ. And then here's a list of all the different STEM labs. I'll try to scroll a little bit slower. So as you can see, there are quite a few. And you can actually break them down. There is a menu by sensors, coding, or engineering. So based on what you want to teach the students, whether you want to teach them about gear ratios or mechanical advantage, or whether you want to teach them about how sensors work or coding. But as I mentioned, there is a teacher's portal. And for me, it'll just let me log in because I'm already signed in. And this is what gives you all of your resources. So it gives you pacing guides, and these are great. The pacing guide gives you a basic overview of each one of the lessons, and it actually breaks it down into different courses. So there's a 6-week course, a 9-week course, a 12-week course, and an 18-week course. And of course, this is a Google Doc. So they encourage you to download this, put notes, modify it, etc., and customize it yourself. There is the content standard. So if you are worried about making sure that all of the standards are met, it does list all of the standards here. For a lot of the different categories. So, and the lesson plans are actually listed across the bottom. So which lesson covers which standard. There's also the material list. So this is really important because it makes sure that you have everything you need. For instance, if you were going to use the STEM Lab Movement Challenge, it tells us that in addition to our VEX IQ Super Kit, we're going to need paper, ruler, markers, blocks, etc. So it just makes sure you have everything you need. There's build instructions. So this is also a way to get to all the different build instructions. So in the top left, you'll see we have Fling. That's the hero robot for this year that will
Okay. Mhm.
bring the robots in and shoot the ball, as well as all the other robot builds. And these are great tools as well, because your students may get an idea, say, you know what, we want to build some type of mechanism. And if they go through here and look at the different robots, they may not want to build that entire robot, but they may be able to look at the instructions and see how VEX engineered that type of a mechanism, and then use that knowledge to build a custom robot. You can also access this from the VEX website. If you just go to downloads, and you'll see build instructions. And that will take you again to a list, and you can click on VEX IQ, and that will get you back to that same page as well. There are also, of course, marking rubrics, checklists, a letter home if you do that type of thing, or an email home where you explain to the parents what they're learning about. And then there are some overviews as well. So there are quite a few resources here to help keep you organized if you choose to use the STEM labs, whether you're bringing VEX into the classroom or still using it as a club.
Okay, so STEM lab is for the teacher, not for the students, or students also can access it?
No, the students can access it. They just can't access the teacher portal without an account. So from the student's view, it'll look like this. And if you say to them, okay, students, I want you to do, the lab on drive forward and reverse, they can come right into here and they can just step through. You can see there's the lessons, and they can go through on their own and do the lessons, or you can do them as a group. So these are designed that you can do them either way. But the students can do them on their own as well.
Thank you.
No problem. Have you been using, are you familiar with VEXcode VR? The virtual robotics programming platform?
I kind of made myself, I'm kind of familiar, but I didn't use it. I tried a few times, and one of my students tried also, but I'm not very, very familiar too.
Okay, because what a lot of teams are doing, because one of the biggest challenges is once the students have the robot built, it's very difficult to get them to put the robot away and start coding. So what some teams are doing is they're actually getting the students to learn the coding portion first, or at least the basics. And the way this works is we start off by opening a playground. And what this does, I'll make this a little bigger so it's easier to see, is we actually get a virtual VEX robot. And you'll see it looks a lot like the autopilot bot. So they get their own little virtual robot, and then what they do is they can start coding. So especially for students, if you've got new students that maybe aren't familiar with coding, it's a really easy way. They can put a couple blocks together, hit run, and now you've got your robot driving around. So one of my favorite activities for students is the wall maze. Because let's face it, the hardest part of coding the VEX IQ robot for any competition is getting the robot to the exact right space you need it. And this is a great exercise for them. So what they have is they have a 3-dimensional maze here, and they've got to code their robot to go through the maze. And as you can see, it's a pretty tight space. It doesn't leave a lot of room for error. So if your students can start using the commands and coding the robot to get all the way through this maze, it's a really good introduction to coding. And it also gives them some confidence at being able to spend the time and code the robot to get exactly where it needs to go. So this is a great resource that works really well in tandem. And what's great about it is it's just a website so that any student can use it from anywhere on any device that's got internet access. So you can give your students homework and say, okay, tonight or this week or this weekend, we're going to code our way through a wall maze. Or if you're teaching them about how to use sensors, this is a great platform as well, just to take the robot out of their hands so they're not fiddling with the robot or with the controller, and they're focused on the coding. And there are quite a number of different playgrounds so they can have a lot of fun. Another favorite with a lot of the students is the Castle Crasher. And in this case, what they actually do is they can actually knock buildings over. So the boys especially love this. and they can knock buildings over. And you'll see that this playground has no wall around the outside of it, so they can actually push all the objects right off the edge. So again, if you're looking at taking your coding to the next level, this is a great way to get your students started coding and having fun. So when the robot's ready, they can just dive in and get the robot coded.
What I do usually, I'm just gonna tell you what I do. My students start with code.org.
Mm-hmm.
And then they learn how to code from there. And then when they start with robot, then it's kind of easier. But this year, is it okay to start with that one and then encode this, or we just start with this one also?
Yeah, absolutely. And if you're already doing the code.org, they're getting the basics of coding, which is great. And just, I mean, I would give them simple exercises in this, probably the two I just showed you, and that'll just take what they've learned from code.org and show them how easy it is to take what they've learned and code a physical robot. Yeah, absolutely.
Mm-hmm.
Or, I mean, you can give them the option. You can say they can code Castle Crasher, or they can code the maze, or you can give them both. You know, just let them have some fun with it.
Okay.
So are there any more questions?
You know, I can't, it's 2 years past already. We are not doing almost anything. Or maybe 1 year. For me, it's too.
I know it's overwhelming, but I do mention to everyone that takes our webinars that if these questions come up later, I'm always available for support. So feel free to send me an email. Sarah will include my email in any correspondence, and you can always just reach out to me with any questions you have, any issues you're having, etc. And I'm always happy to help.
Okay, and I noticed that you are recording this. Is there any way you can just send us the email us the recording, or?
Yes, I believe Sarah automatically will send you a copy of the recording, and that way you've got it for your resources. And the video I showed you is also available on YouTube. So if that's something you haven't been using that you want to make sure your students are aware of, you can just play it off YouTube for them as well, the video about the VEX IQ brain menu.
Okay. Okay, I have no more questions at this time.
All right.
I'll keep the rest for the next one.
Perfect. And the next one's more fun. We get to do some coding. If you have access to a VEX robot and you want to, you know, join in and code along, or you're welcome to just sit, relax, and enjoy. Again, Sarah will send the video recording of that. So if you wanted to follow along afterwards and try some of the coding, you'll be able to play that recording, and then you can pause it, test things, etc. So we'll really get your coding working.
Okay.
Well, thank you very much for joining me today, and I look forward to seeing you on Thursday.
Okay, thank you very much. Okay.
No problem. Have a great day.
Thank you. Thank you.
Bye now.